Okay, it's go time. All right. So, first day of full people in the classroom. It's awesome. All right, so day 4. I want you to understand this, and this can be repeated over and over and over again. That what the last thing that we did, which was the empirical rule, is just an estimate. I know I'm sick of hearing it, Mr. S. Just want to make sure you understand that we got something different going on today. By the way, everyone picked up a sheet when they walked in, right? Okay, mine's purple and it's laminated, but you got that chart in front of you? Okay, and then, I think I am showing my, so Z-score chart, all right? That's what we're going to be dealing with now, which is slightly different than the empirical rule. And also, the problem with the empirical rule, it was great. I have a mistake on our worksheet. The first 4 questions are empirical rule questions as a review. Then the rest of the questions are what we're doing today. Very simple. Okay, but there's a mistake on the chart, and mistake is the very first sentence. The only way the empirical rule works is if you are exactly spot on 1, 2, or 3 deviations from the mean left or right. If you have a z-score of 1.34, empirical rule does not work, and you can't find those probabilities. So that's what we have today. And then I'll show you how that empirical rule is an estimate. The chart that I show you there is actually shows that the empirical rule is a little bit off and is not a perfect indicator of probabilities. But just as a reminder, remember these are standard deviations, 1, 2, 3 to the right. I should have made that a little bit more symmetric, but and then this is -1, -2, and -3 deviations to the left and right. Remember, mu represents mean, or x bar if it's a sample. I'm trying to think of the right thing. Remember, this is the mean, but you know what? This is also the mean being equal to the median and the mode. That is a standard normal curve, okay, where we are perfectly symmetric, all right? So those 3 things are actually equal. The mean is the most frequently occurring value, just like that weight example on the beginning of our notes Thursday, Friday. The mean weight of a male was 200 pounds, I guess. Well, that's the most frequently occurring value because it was the highest part of the curve. So that's why mode can be used there as well. Okay, and then I gotta get a copy of something here. So hold on for a second. Don't look. Copy. Where you going? Did you not pick that up on the way in? Oh, okay, got it. All right, let's see if I can get this in here. Bang, come on, paste. Nah, it didn't work. Okay, so I'll have to, geez, this is the worst. I hate this program. I'm just gonna go to the other note thing. All right. Here's what you want to do now. Let's write this down in your 1, 2, 3, 4. And then I'm going to look at each one of these as we look at our charts. And then also show you how the chart is a little bit off for one value of the empirical rule. And actually I'll show it up here on the screen instead of holding up our z-score chart here. Okay, so I'm going to take one sentence at a time and go to the z-score sheet so that you know how to read it. So it's going to be a little frustrating. So get sentence number 1 done at least. The cumulative area is close to 0 as the z-score equals -3.49. Stop. Go to your z-score sheet. Now I'm going to tell you how this z-score sheet works, or actually they're going to tell you. So these are z-scores off to the left, -3.4, -3.3, so on and so on and so forth. Okay? Now, notice what it says. These areas listed in the chart are the areas left of the z-scores that are listed. So the very first thing I wrote on the notes was, as the z-score equals -3.49, and there goes my pen. That number right there is the area left of negative 3.49 as a z-score. So let's make sense what that actually means. Let's go back to the weight, and let's not be all sensitive about, what if I weigh this, and again, this is just all about data. Believe me, I have a high z-score for weight. I don't want to tell you how much I weigh, but my z-score is greater than 0. But a male that's an adult weighing like 50 pounds, that is not likely to occur. Their z-score would be negative 3 point. This is what we're saying. So they would represent only higher than 0.0002 of the data, or 0.02%. I don't know why I put an approximation there. So somebody that weighs like 50 pounds, when the mean is 200 and it has a certain standard deviation, they would not be very likely to occur. That would not be a likely occurrence to find somebody that's an adult that weighs that. It happens, but it's not likely. Do you understand? Kind of, sort of? Okay, but also really what you need to understand is that's how you read this chart. These are z-scores, and they give you all of, negative 3.3 to negative 3.4. That's what the numbers all the way to the right represent. Okay, let's go back to this. Back to the note sheet, which I think I'm on 2 here. I think. Oh, actually, I was going to 1 here because my program is annoying. All right, as the z-score increases, the cumulative area increases. Now, let's just take a moment to look at the z-score sheet. They had to make a decision. In listing the z-scores, they had to decide, all right, when I give you the z-score, what should we make the areas, left of or right of that z-score? They went left. And that's how the z-score chart works. So let's go to the third thing. The cumulative area for z equals 0, of course, is 0.5, which represents 50%. Oh, boy. Just trying to get the pen to activate again. It's the annoying computer of all time. I think the last one was worse a little bit, but this one's only the pen. So let's go to that z-score sheet again. Boom. Actually, 50% is on both sides. Look, negative 0 as a z-score. Is there any difference between negative 0 and positive 0? Yes or no? That's why when you flip to the other side, it starts with 0 again, and you have that 0.50% right there. And that is exactly what we told you through the empirical rule. Right at a z-score of 0, 50% of the data is below, 50% of the data is above. 50% of the probabilities, let's say. So both sides have this. So notice on the left side, all of the probabilities are less than what? All of these probabilities are less than what? 0.5. And then notice on this page, all of the probabilities are greater than 0.5. So it's again understanding the sheet, right? Which I did this with seniors, and some didn't, and some it took weeks to get this sheet figured out. We're not waiting. You have a test on this Friday, you will need to use the sheet. I will give you a nice laminated copy. Do not lose that copy that you have in front of you. You'll need that the rest of the week, okay? And then I'll give you your own. My copy has like little Star Wars stickers on there. May the Force be with you. It's awesome, okay? I like these sheets. And then I highlight the shading just to really, okay, nobody cares. And they're purple. I like that color. Okay, let's go back to the notes. Not that one. Let's get this one, because why would you move? Why did it move? Okay, and then I could go to the last one. The cumulative area is close to 1, which actually represents 100%, as z gets to 3.49. I do want to make a point of this, though. You don't have to worry about this, but I'm letting you write this down. When I go back to the sheets, I'm actually going to verbalize this right now. Let's talk about Albert Einstein and IQ, and the IQ standard normal curve, which was listed on that one sheet. Where do you have standard normal curves at? What kind of data? IQs. I guarantee that Albert Einstein's z-score is greater than 3.49. Like, he's probably off the charts. Z-scores exist like 5, 6, 7, 8. Who do we appreciate? It's so unlikely to happen. And it is so unlikely to have a human being like Albert Einstein. The things that came out of his brain were just remarkable for the time that he lived in. What an imagination, what he came up with, and then ended up being many things proven to be true much later in years. So anyway, I just want to make sure that you understand it doesn't end at 3.49. There are z-scores that are higher than 3.49 and lower than negative 3.49. And let's go back to, the z-score chart. Let's go to the other side. And then here we go. 3.49 as a z-score. That is, and again, I'm just doing this again to get you to read the chart. Yellow and blue make green. So it's the green value that I'm looking for here. Boom. That means for a z-score of 3.49, 99.98% of the data is below that. So it exists. There is a z-score of 4, 5, 6, but it'd even be more minute of a percentage how many people lie in that percentile or lie in that area. So just want to make sure you understand that. Okay, then let's talk about the empirical rule. Quick question.
So to read this chart, going up to down is in tenths at tenths place and...
Oops, shoot, I'm screwing up here. Hold on, I'm trying to remember how to do, am I taping? Where's the thingamajobber? Oh, there it is, I got it. So out of practice. Pause. Okay, so here we go. Sorry, just jumping back and forth between notes here. So I filled that out. Okay, all right, so what are we going to do here? Find areas under a standard normal curve. I just want to get my wording right. I got to take my headphones off for a second. A little unprepared. A little out of practice for this, daily thing. Where did I do it? I always do this to myself. I always put my sheets in weird spots. Darn it. I'll be right with you. Am I taping this right now? I should have pressed pause. How do I lose my sheets? What did I do? Oh, I'm so mad. I just want good wording. I print it out just to make sure I write the same. This is just embarrassing. Everyone just wait for a second. Let me press pause. Maybe. Oh, I hate this pen. This pen is going to be the end of me. Okay, Mr. Samuel says combobulated now. That's the opposite of discombobulate. That is a word. Number 1, sketch. It's not even that hard what I wanted to write here. I just panicked. So you want to sketch the z-score. And I'm going to ask you to do this on a test. It's very simple. You'd be amazed how easy the notes are today. And shade the area. Now this is definitely a wax on. Anyone? Wax off day. Like I said, we're really ending this Friday because it's really not a lot. But this thing that we're doing, these silly little questions today and then Wednesday, is the backbone of what we do all year long, really, in a stats class. Dealing with these normal curves and breaking them down and getting these areas. Looking at the z-score chart, they have that all year long, that z-score chart. And then more. Then there's some more tests with different charts. So once you get the z-score chart down, future charts aren't that bad. And then use the table to find your areas. Oh, I know what I was going to do. Do you remember before I go into this next example? Scatterbrain Mr. Samuelis here. Remember I told you how the empirical rule is just a little bit off? Okay, so how much were the tails worth at the end after 3 and negative 3? What was the last percentage?
0.15%.
It's 0.15% each corner, or each end, right? Right? Okay, so that is at a z-score of 3, negative 3, right? So let's look at our chart real quick for negative 3 as a z-score and show how that is just a little bit off. And it's right here, negative 3.0. What is that supposed to say? That's supposed to say 0.001 what? 5. Here's my point. The empirical rule is a nice little ballpark figure, but it's not exact. And then you'll find that if I went to every whole number z-score, they're off by a little bit, but not much. So that's why the empirical rule is a ballpark figure. All right, so I did want to do that before we continue. Now watch how easy the notes are. This is going to be redonkulous. And then you'll have definite time to do your work. So 4 cases. And again, a wax on, wax off day because we do do areas left of, right of. We do two-tailed tests, which is area left of this and also right of that. So that's the fourth example today. So don't think it's silliness that we're doing this. It's actually important in stats. Okay, and you don't have to always write this, but you know 0 is right here. So 1.79 is approximately like right here. So when you're making, and try to make a nice little curve. I didn't give you notes because it's not necessary. Today is short. So that's what I'm looking for. I'm looking for that area. I'm looking for all the probabilities that 1.79, that's everything less than that. All right, and you'll see that worded that way on Wednesday. Well, let's go to the chart and exercise what that means. 1.79 is 1.7. And then again, yellow and blue make green. And it was 1.7. I didn't go far enough with the yellow. Maybe my pen stopped again. Oh, there it is. Okay, and then I can just get this in blue here. All right, going up from there. So 1.79 gives me a percent of 0.9663, or 96.3% if I'm going to say percent. Whoops. Okay, having trouble toggling between notes. And then when I toggle back, it always puts me back up there. Thanks, program. Much appreciated. So for a z-score of 1.79, I get a probability of 0.9633. Did I remember that correct? Or 96.33% of the data is below a z-score of 1.79. Quite a bit of it, okay? All right, let's go to the next one. And then I got to get rid of this because the program betrayed me. I think, oh my gosh, I can't even function on this this ridiculous program. Come on. Delete. Did I just delete the whole page? No, okay, I'm good. All right. And I know you don't have notes, so go ahead and write that real quick and then draw real fast standard normal curve. So z-score area right of. Okay, well now is the time to remember how the sheet works. And again, the sheet had to pick which way they wanted to shade the regions. But everyone should know that I'm looking for these probabilities. What should the answer be? Less than 50 or more than 50? Oh no! Look at that area. What should my answer be? Less than 50 or more than 50? Less than 50. Unfortunately, our sheet is constructed in a way where when I look at 2.03, got to zoom back, I am getting the area left of. So 2.0, okay, I don't have to go that far. 2.03, that's what I get. I get 0.9788. Okay, darn it. That's my fault, nobody else's. So 0.9733, is that right? What do I got to do for this, though? What do I do to get the blue area?
Minus out 100?
Or what number, because this isn't in percents. Not 100, move the decimal 2 to the left, and it's what? 1, that's what I was looking for. Okay, because I don't have this in percent form, I have it in decimal form. So here is 0.977. That's 0.97733. I want the opposite of that. I want the blue. So it's 1 minus that. Am I right on the percent or no? Or decimal?
9788.
9788. Thank you. I saw a hand go up, so I knew something was wrong. And then what do you get for that?
0.0212.
Or 2.12% of the data is right of that number. Z-score. Okay, between, yes, this happens all the time. Actually, the last one happens. There's something called a two-tail test in stats. But anyway, negative 0.93, that's approximately right here. And then here's 2.16, I don't know, somewhere right around there. You don't have to be, I'm not going to get a measure out. So this is what I want. But here's a problem. Don't you know when I look up the z-score 2.16, it's all of this, correct? Right? And then when I look up, I'm going to color this in blue, 0.93, I get all of this, right? Which actually, let's just count that as green. What color do I want? What color is the answer to this question? Is it yellow? Is it green? Or is it yellow plus green? What's the answer? It's just yellow. So what do I have to do? I have to find these probabilities. I have to find this probability. And I have to find this probability. And what do I have to do with those two probabilities? Subtract them. Okay, that's how I get the yellow. This is Mickey Mouse stuff. This isn't like high complicated math. Just looking at this picture. This is why we graph it, so that we make sense out of this. All right, but then there's a problem. How do I find the second probability? That's just like the last question. First probability is easy. Negative 0.93, right? I'm not highlighting anymore. Was it negative 0.93? Is that right? Yeah. All right, so it's negative 0.93. It's I guess I got to zoom this down. Okay, and then I'm going to circle it. Is that 0.1762? Did I get that right? Yeah. 0.1762. So it is, oh, do I have these reversed? I actually have them reversed in the notes, don't I? Anyone notice that? I got to switch these. It's this probability that I'm subtracting from the other one. Okay, so it's 0.216's probability minus 0.193's probability, because I got to get that out of there. So, I'm sorry, what was that? Point what? 1762. That goes here. And then the problem with this one is, boy, I might have reversed that in the other class. 2.16's probability, which is awfully large. No, I don't think I did. I think I'm thinking of my last one here. Trying to find where I'm going here. And then what's 2.16's probability? 0.9846. 0.9846, right there. Making sure that's the 6, yep. 0.9846. Hitting the wrong buttons. 0.9846. And then what do you get for an answer for that? 0.81 what? 84. Or, there's the pen, 81.84%. Okay, then last but not least, wax on, wax off. Yes, there are things called two-tailed tests. Did you get a different answer? Somebody get something different?
I got 80, 0.80, and then
0.8084.
84.
Are you using a calculator or trying to use just your head? Which one's right? Is it 80.84?
No, it's
80.84? How many people agree with that? Okay, it seems like the majority rule. I don't know. You guys got the calculators.
Okay, I see what I'm doing.
Okay, all right. And then area left of, here's about negative 1.96. Negative 1.96. I don't know if I said that right. So that'd be easy. And right of 3.02, which is way out here. So if I want both of these areas, what do I have to do with these two areas? What's the situation I got to do? Add them. I got to get that probability, and I got to add it to this probability. So this probability plus this probability would be area left of this one and also right of this other one. The word and does mean add. So the negative 1.96, I'm not going to the chart anymore. If you don't know how to read that at this point, I think there's something missing. 0.0250, sorry, right? Now that's good because that is the area left of negative 1.96, the way this sheet is constructed. But for 3.02, you should have gotten, isn't it 0.9987? Notice how 3.00, 3.01, and 3.02 are all exactly the same. Do you see that? And it's just how it happens because we're getting in. But what do I have to do to find this area? What do I have to subtract from it? What it has to be in these parentheses? 1 minus 0.9987. And you can go ahead and calculate that. I'm not teaching. If you type that in the calculator, you just got to be careful. Don't make mistakes on that. Okay? Good enough. Now go ahead and start your homework, and I'll go ahead and compose this video.